I'm Llewellyn King, the host of CFS Alert. Today we're in Boston, at Massachusetts General Hospital, where we're talking to a very interesting researcher. He is Michael VanElzakker, and he has been looking at the brain and how this disease, this terrible disease with its awful consequences for so many people, may in fact be influenced by the brain and the nerves of the brain. Michael, welcome to the broadcast.
Hi, welcome.
Tell me a little about yourself. You are a neuroscientist. You're not a doctor.
Right, yeah, so, PhD researcher, not an MD clinician.
And you've been doing this at the hospital for about 8 years?
I've been working at this hospital for about 8 years, and I just started getting into CFS research sort of formally since maybe 2013.
And your previous interest was, or your coincidental interest is post-traumatic syndrome.
Right, yeah. So my training and specialization was largely stress and memory. And I sort of got into this, as many people do, because I have a sick friend.
It seems to be the primary way that we all get into it, is we have somebody we know and care about who is sick. I can tell you about several doctors who've done that. It's true in my case. My friend Deborah Woroff, a co-host of this program. And so you too. This is interesting and in a sense a little disturbing because it's so happenstantial that it has no science to it.
Right.
There doesn't seem to be a mechanism to bring this disease to the attention of researchers and potential doctors so that they can specialize in it, or at least have a large base knowledge of it, or any knowledge of it at all.
We did a panel at Harvard Medical School 2 nights ago, and they literally don't learn about this condition. At least that's what the third year said. Maybe they get into it in the fourth year. But yes, I mean it is true that most people that I know have gotten into it because they know someone with the condition, and I think partially it's because it's sort of a powerful within subjects study design in which you know someone before they were sick. And then you realize that some of the explanations that have been given for psychosocial model of this condition don't fit what you know about this person. So the person that I know who's very sick, had to drop out of law school early. She really had to put her life on hold. And it's not the case that it makes any sense that this is a person who became obsessed with the identity of being sick. And finds that sort of reinforcement valuable, and that's the reason she spent, decades in bed with migraines and vertigo. So I do think there is a personal connection for most people, and you're right, because part of the problem with that as the model for people gaining interest in this condition is that there's no specialization, and also that you end up in a situation where there's a researcher or clinician who didn't specialize in this condition trying to figure out how to do research in this condition. So you've got, something like an orthopedic surgeon with a sick child or something like that, and they're now trying to do research on this condition and maybe don't have the training or background.
Your research does not involve the traditional laboratory with samples and beakers and test tubes. But primarily computers and brain waves, analysis of brain waves, brains under various scans, that kind of thing.
Right, so we're a brain imaging center, exactly. So people come in here and we can do lots of different types of techniques and look at different types of information with brain scans. But in general, at least here, we don't focus on blood, biome, and things like that. We're not set up to do that. We can have it ordered, which we sometimes do if there's money.
How is it coming? What are you learning?
We've got 3 studies up and running. I have 2 studies up and running. One is we're trying to get off the ground. But in one sort of a pilot study, we've used combined PET and MR imaging. So PET is the type of brain imaging that uses an injected radioligand, so a small amount of radiation that attaches to something happening in the body that we then can image. and at the same time we're doing concurrent MR, magnetic resonance that has very good spatial resolution. So we've got one study where we scanned a handful of patients. It's interesting. We sort of use that as pilot data to apply for more funding and things like that. But we've seen, some of the things that other studies have seen, hypometabolism in some of these brain structures, including the thalamus. And we've got another study that is now up and running where we're doing brain scanning before and after an exercise challenge. So we understand that exercise is provocative of symptoms, and we think this is an important thing to try and understand. So it's a symptom provocation study where we deliberately make people sicker, but we're able to scan them at a baseline state, have them do an exercise challenge, and then scan them again when they're sick.
And it's axiomatic that if they take exercise, they will have serious consequences.
That seems to be sort of the primary. It's one of the most descriptive symptoms of this condition, yes. Yeah.
Looking at the brain at work, as it were, what have you learned so far? Is there anything that stands out?
I was surprised by the extent to which, so the thalamus is a brain structure that most senses, sort of like from your eyeballs, it goes through the thalamus before it goes to the cortex that processes it, including hearing and other senses. And I was surprised the extent to which there was hypometabolism, so less activity going on in the thalamus in our hands in a small number of patients versus controls. So I have a sense that may be why there's so much sensory difficult in individuals with this condition. Part of what that structure is supposed to do is some filtration. So for example, there's a sheath around the thalamus that turns on when we sleep, and it's the reason that if I'm next to you going like that, you won't just automatically wake up. And it may be the case that is, we don't know for sure, but it may be the case that this is part of why bright lights, loud noises, things like that can be painful for people with this condition.
There's a lot of research going on into things that happen in the gut, and you're looking at the brain. What's the relationship of the gut to the brain?
It's extensive, really. So there's an entire nervous system called the enteric nervous system, which is the gut's nervous system. So there are multiple ganglia in the gut, which, less evolved organisms, that is their version of a brain. So there are many organisms that only have ganglia as opposed to a brain. And so we have as much processing power in our gut as some organisms do in their entire body. So there's a lot happening there just in terms of the nervous system right in the gut. But there's also a connection between the brain and the gut, which is primarily the vagus nerve. It has ongoing on an ongoing basis, it senses the milieu of the gut, including the inflammatory status of the microbiome, and it sends a signal, an afferent signal up to the brain to let the brain know what's going on in the gut.
Now, the vagus, you're very associated with the vagus nerve. You've done a lot of work on it. What have you discovered about the vagus nerve?
I think that this is at the very least a central mechanism of this condition. I don't want to be dogmatic about saying that this is the smoking gun, and I'm not sure if we're going to find a smoking gun, but at the very least I think the mechanism of vagus to brain communication of inflammation is an important mechanism that drives the symptoms of this condition. It's a difficult thing to image. That's part of what we've been working on, is trying to figure out how to do that, but it's very highly branched all over the torso. So it's not the case that you can really sort of pick up one particular spot because it's kind of everywhere. So one of the things that we've been looking at is the point at which it enters the brainstem. And there are deep connections between where the vagus enters the brainstem. It's a structure called the nucleus of the solitary tract, and the thalamus, which is the structure that I talked about before. There's a Japanese group that's done some work using PET, which is a study that we're going to try and replicate, and I think improve upon a little bit, that has shown connection between the brainstem, which there's a lot going on there, but to my mind, the important part is that's where the vagus nerve enters the central nervous system, and the thalamus, and they've shown a sort of a wide swath of inflammation along that pathway.
Michael, something you said there's no smoking gun, or we don't think there's a smoking gun, which also implies that there's no silver bullet, so that you're thinking of this as a disease with many causes, many solutions, more like cancer than something where you can one day hope to get a pill and it's taken care of.
I mean, that may not be what people are hoping to hear, but that is sort of more and more how I think about it, is that there's a cluster of symptoms that are at an endpoint of some shared processes. And there are a bunch of conditions that seem to have sort of an overlapping mechanism. So Ehlers-Danlos syndrome, mast cell activation, this condition, ME/CFS, they seem to overlap quite a bit. And it probably is the case that there's something driving inflammation towards the brain. It may be a viral pathogen in some folks. It could probably even be injury in some. There's probably a sensitivity to mold for some people that gets picked up by mast cells, which the vagus nerve synapses directly on. So I do think that there are multiple paths that can lead to the same types of symptoms. That's my suspicion.
But there seems to be one commonality, if there is a commonality, and that is most people remember when they were first struck down, almost to the time, and that suggests that there's some sort of common trigger, as it were.
Yeah.
Because otherwise they wouldn't remember it that
Sure.
way. There's a commonality there between all of these very disparate things. And how does that fit into your research?
Yeah, I mean, I would say that there is the commonality of having a trigger. Whether or not it's a common trigger is an open question. But so, for example, it could be the case that in some people, in the same way that you or I, when we catch the flu or a cold, might get a cold sore on our lip, right? Mm-hmm. That's the reactivation of some latent viruses, a herpes strain of virus, that sort of wake up again when the immune system is compromised. The same thing happens inside of the body. So it may be the case, I don't know this, but it may be the case that in a bunch of people, they've had sort of a reactivation of a herpes virus. They like to live in nerve tissue, so it may be the case that in some folks, a herpes virus has reactivated on nerve tissue, on a neuroimmune nerve. It doesn't necessarily have to be the same pathogen that does this. It just has to like nerve tissue enough to activate there. But yes, it does seem to be the case that in a lot of folks, there is a triggering episode, and whether that's the same exact pathogen in everybody is an open question, I think.
When you come to look at this, one of the things in medicine and in all other science tends to be a siloed medicine. This person searching that person searching this. And everybody knows about this problem, but it doesn't necessarily go away. What do you do to talk to clinicians, to share what you're learning with researchers and with clinicians?
Yeah, I mean, it's a tough question. I think somewhat has to do with the fact that in order to understand extraordinarily complex systems, you have to simplify by cutting nature at the joints. And I think it's the case that this is an example of a condition that sits at the intersection of a couple of those divisions. So immunology and neurology, for example, are traditionally split.
So you're on the bridge between two silos.
I think
use a
that's
different analogy.
Exactly. I think that's the case. And GI docs, generally speaking, are separate from neurology. Neurologists. And it may be the case that there's sort of an intersection between the two conditions. So yes, I mean, I think that in general, overall, doctors want to do the right thing and they want to help. I know a lot of patients have had bad experiences with specific doctors, but I think that overall they want to help even if they're wrong. And in terms of how to get doctors to be more aware, I mean, it's a tough question. I mean, it's almost a human question. How do you get someone to sit down and and listen to something that you think is important. I think the film Unrest is
This
really
is
helpful.
Jennifer Bray's very marvelous film.
Yeah, it's a really
Of work. It's an exceptional documentary and very watchable.
Exactly. I think it's a really important piece of advocacy that tells a very human story in a way that I think can be engaging to doctors. But how do you get them in a room to sit down? And, we're working on that. So we've done a lot of sort of public outreach. I've shown it here. We had a room full of people.
This is one of the great teaching hospitals. Do you teach ME?
I teach it every chance I get.
But the hospital does not have it in its curriculum yet.
Harvard Medical School does not teach this condition specifically. Exactly. That is my understanding. Yeah.
And this is the case in most hospitals and most
I think that's
teaching.
True. Yeah.
So that is a very important bridge to cross. To at least have an understanding, so that years later, as a GP, a doctor will know what it is or what it might be.
That would be a really important shift, is if we were able to get this condition sort of regularly taught in medical schools in a good way, because you can teach it poorly as well.
That's interesting. How would it be taught well as opposed to poorly?
If you ask me, if it's taught well, then we would be focusing on the neuroinflammatory components. We'd be talking about immune. The immune correlates. We'd be talking about the endocrine factors of it. If it's taught poorly, when it's taught poorly a lot, it's focused on the sort of drama in the field. So people like to still talk about the XMRV controversy. They like to talk about, obviously the psychosocial model is something that people like to talk about, or even just the controversy over that model, as opposed to mechanisms that we have reasonably well nailed down, the problems with metabolism and things like that.
What are you seeing in the brain with the few medications that are used, like medications that are being tried off-label? Rituxan B is one. Do you watch that in the brain?
No.
Or Ampligen? You look at the effect of
I've
that
never
in
done
the
any
brain?
sort of like a clinical trial pre-post scanning. I wish that more, I think a significant problem in this field is the use of subjective outcome measures. So the idea that we just fill out a questionnaire before and after some manipulation to say, how do you feel? Those are notoriously unreliable, even if people have good intentions. So I would love it if someone did before and after brain scans. That's what I'm building towards. That's the reason that I've set up my scans the way that I have, is so that they can be a pre-measure. My long-term goal is to do some sort of a clinical trial, or at least have a protocol with which someone could do a clinical trial, so we could do pre-post objective measures of post-exertional malaise, for example. Give some sort of a manipulation, whatever it is, whatever you think is going to work. I have some ideas about things I'd like to look at.
What do you need more of in your work?
Well, you can always use more funding. The PET scan that we're doing is fabulously expensive. It's $5,900 per patient. The fMRI, the scans are $800 an hour. The exercise challenge is an invasive one, which I didn't really talk about, but it's about $12,000 each for one of those. So it's
How does that work?
The invasive exercise challenge. I really love this. It's a guy named David Sistrom is a pulmonologist at Brigham and Women's. He's a really sharp guy.
Another Boston hospital.
Yeah, exactly. He's a really sharp guy, and he's developed a protocol in which someone can do the standard VO2 max exercise challenge that everyone's doing in this condition, where they're on a stationary bicycle, pedaling at a certain 60 hertz or so, as resistance increases by the minute. So the whole challenge lasts maybe 6 to 8 minutes. It's not, it's difficult, but the bike wins. You don't actually run until exhaustion. You run until you can't keep up. And the bike is going to win because you physically can't get past the resistance, but it's enough to trigger a post-exertional malaise. But what he does is in addition to the standard sort of measuring of gases and things like that, he does an indwelling arterial catheter, one that sits in the pulmonary artery and one that sits in the radial artery, so he can sample blood on an ongoing basis as it enters the lungs fully deoxygenated and as it exits the lungs fully oxygenated. And I think oxygen use is probably important, or lack thereof, is probably an important component of this condition. And so we can have a whole bunch of different measures during the exercise challenge proper. Meanwhile, we scan them before and after when they're more symptomatic.
In conclusion, tell us about identical twins and where they fit in your research.
I've done a lot of work with identical twins in the post-traumatic stress world, and I've been able to scan a couple sets of twins in this condition, not enough to make a study out of, but I'd love to find that. If anyone has an identical twin who's healthy, if any patients have an identical twin who's healthy, I'd love to get them out here to scan. But even siblings or family members, I think, are a valuable control. So that's one of the things that we're going to try and do in this study, is to use first-degree relatives as healthy controls if we can. So that controls a little bit of the noise variance in our outcomes.
Michael, you're an extraordinarily interesting man, and I'm sure that the viewers to this program will be very glad of you and the work you're doing. Cheers.
Thanks very much.